please stick your hand up because I can actually see you if there's a problem, if you can't hear me or you have a question. So this presentation is really on, is renewable energy all that it's cracked up to be? We do have commitments for net zero emissions on the Isle of Man, and of course a big part of that will be power. So, first I give Gail a great thanks because she got me at least started on this journey. We had a presentation in the start of 2020 where we discussed a lot of things, but essentially how climate change would affect the Isle of Man, but what we could do about that. I'm speaking from Denmark, where renewable energy, we were sort of pioneers in the wind energy, but now, believe it or not, we're growing hazelnuts. We've got lots of vineyards here. Climate change is actually, if you're a farmer, has been actually a good thing in Denmark. Our minds will change if the sea level rises as those glaciers melt, but at the moment the climate has changed, but you'll see not always in a good sense. I'm not sure EasyJet are quite ready for the hybrid airship yet, but that was another idea we had at the time. And also I'd like to thank, we've got some new, younger members of Energy and Sustainability Centre. I say 4.5 years ago when we did the UTM talk, ambition was high, and it was just after James Curran's report had been released, the first reading of the climate change bill. We set up the Energy and Sustainability Centre really to build knowledge together, but actually, unfortunately, maybe in 4.5 years, not as much has happened as we'd hoped. But our sponsors and ourselves are more confident now that things are going the right way. One or two have lost patience, but we are continuing to carry out research and hold events, produce animations, write articles. They're all available on our website, which is shown there. So the question really is, as you know, there's been, not everybody is pro-wind, for example, on the Isle of Man. So, of course, the question is really, which is the biggest threat, climate change or the green transition? In either case, how will it affect the environment, the economy, and our lives? Climate change and or that we're going to move away from fossil fuels. Now, one of the threats to the Isle of Man, to the economy, of course, is environmental, social, and governance, essentially sustainability. Many companies, many of the international companies in the Isle of Man are committed really to lower the emissions to zero, and that's not just themselves, that's also their clients and their customers, so all their suppliers and their customers. So really the Isle of Man has to, if it's going to continue to attract international companies, it's going to have to, power being one of the most important parts, is going to have to be non-fossil fuel in origin. So, of course, one of the problems is resistance to change, but we were very innovative on the Isle of Man. Electrification came early to the island. We embraced renewable energy in the form of hydro in this case, and just to give you some idea of the sort of figures we're talking about, if you ran the Manx Electric Railway downhill from Snaefell, we'd produce, if we could store it, we'd produce about 17 kilowatt hours of energy, which would be enough to power one Manx person for 8 hours. We need an awful lot of black sea wheels. Turbines have come a lot further nowadays. So now, of course, part of this was because the risk was taken by private enterprise, and that's what we keep on saying, that the investments, people will invest and will take a risk if they see profit ahead. So you know, we do need to involve companies in this transition. Now, one of the things, you know, we were doing a lot of modelling research, and we found out, of course, not all of it is believed, so we thought we'd go to islands where the energy transition is happening. Here's some of them. You know, you can see the Faroes up there in the north, and the Canary Islands down in the south, the Azores, and then some of the Danish and Scandinavian islands in the northeast corner there. The graph on the right shows where they're getting their power from. And in this case, I mean, power is electricity, and that dotted line, black dotted line, is 100%. So what that means is that they're if you reach that line, that means you're providing all your electricity from those sources. And the sources, purple is wind energy. So you see Samso, which is a little island, is producing more than its fair share of electricity. It's exporting a lot, mostly wind. And yellow is solar, which partly supplements wind, and green are other renewable energy sources. On Samso, it's biomass. They use a lot of straw from the fields. Other places like the Azores, which is close to the mid-oceanic ridge, are using geothermal energy. The red is the bad guy. It's the fossil fuels, whether that's oil, often it's diesel on islands, but because we're connected to the UK, we can use gas. Jersey is unusual. It receives power from France. It's nuclear power essentially, which was great up until energy prices went weird a few years ago when Russia decided to invade Ukraine. They've always been going up and down, but we've been in a lull period. And of course, also France is having a lot of problems with its nuclear power. So they're being held over a barrel, Jersey, on this. So they're now looking at offshore wind as a potential solution. If we go, Bornholm is an island in the Baltic Sea. It's part of Denmark, close to Sweden on the west. And we'll just have a look at how they get their power. First of all, they have an interconnector, like we do, and they do import more than they export. But they have a lot of wind and some solar. But in addition, Denmark has realised the most important thing for an island in the north is heat rather than electricity. So they have a lot of heat plants. So electricity is the byproduct from these rather than heat being the byproduct. And they use straw from the fields, and they also, wood chips, they do have forestry, but also they import some, which is the questionable part of biomass. They also have a diesel plant, which they are phasing out, and they have batteries, and they're getting more batteries. They also produce biogas, which is methane, natural gas from animal waste. So another island now the Bornholm is due to become the world's first energy hub, and what this is that offshore wind has to be brought to somewhere, transformed and exported, and there's quite a lot of cost involved in cables. And so the idea is they're going to bring a lot of wind from offshore, the Baltic Sea in other words, and then package it up and export it essentially to Denmark and Germany. And they're going to make a lot of money out of that because building offshore energy hubs are expensive, and this is a natural island. Bornholm, funnily enough, is about exactly the same size as the Isle of Man, and it has a lot less wind than the Isle of Man, which makes you think. Another island worth thinking of, a group of islands, are the Faroes. They have a lot less sun than the Isle of Man. They still do have some solar power, but it's mostly wind again. They committed in 2014 to 100% renewable electricity and net zero emissions from electricity by 2030, which was very forward-looking. So they've basically built a lot of wind, some solar, they've got a lot of storage, and they've got one tiny tidal scheme. At the moment they're 50% renewables, but they will reach 100% by 2030. Now, the thing about the Faroes is they save money every time they put in renewable power, sustainable energy scheme, because they have to import diesel, so they save money. It's basically just making sure they have the investments to do it. It's a locally owned company. The MUA equivalent, SEV, is locally owned. Now, just circled here, Suðuroy, which is the southern island. It's not connected to any of the others, and it's running most of the time on 100% wind plus some hydro. There's a little graph here showing green is wind, blue is hydro. They have some additional equipment to make sure that the grid stays stable, but we'll talk about that in a minute. Now, why change? So I used to work in the oil and gas industry. I always wanted to. I was a geologist, I thought it was great. And then very slowly I realised maybe it wasn't so good, or certainly nowadays we don't need it. And so I was working for Maersk in their oil and gas sector in Denmark, and we started to get really, really violent rains. And you can see here on the right, this was some of the flooding we had. Now, it's only 100 metres to the harbour, so there's a waterfall going off the harbour here, and the commune took it very seriously and really built a whole set of drainage. Very expensive, but now we still get even more violent rain, but it doesn't flood. And then Greta Thunberg, a well-known Swede, was also making me think, and I started doing some calculations and realised that we could no longer justify oil and gas, so I left. It took me still a little bit longer from 2011, but essentially I left in 2019, and I've continued to work on renewables now, or how to get our emissions down. So both in Denmark and in the Isle of Man, an average person is responsible for about 18 tonnes of carbon dioxide each year. Now, what does that mean? It's about 54 average houses of volume, so an awful lot of carbon dioxide. Now, you'll see that really, you'll often see a figure around 7 tonnes. That's what we directly produce on the island, but we also import a lot. And so the imports are responsible for the rest. Now, that amount of carbon dioxide we can't sequester. We need 1,800 trees, new trees growing mature to sequester, to capture that amount of carbon dioxide each year. And that would be representing a new maturing forest of about 5 times the area of the Isle of Man. So really we need to get our emissions down. We can't solve it with things like Miribeg, unfortunately. And it's perhaps not a good story for our biosphere that we're importing so much. Also, as this is a research festival, there's a challenge here for people that want to go to the Isle of Man Greenhouse Gas Inventory, page 3 of the emissions data. It's a really good website they have. There seems to be something wrong with the land use, saying that land is capturing 110 to 115,000 tonnes of carbon dioxide a year. By my calculations at Conti, we're saying every year we're capturing that much, which is representing about 10 million trees. So I think there's an error in there, but I may be wrong, so some other researcher can have a look at that and see whether we are actually doing what we say. Here, as a geologist, I'm looking at what's happened to global temperatures from about 22,000 years ago to present day. And you can see temperatures been rising because it's the end of the Ice Age. Temperatures here is on the left, and a time is on the y-axis here. You can see the end of the Ice Age, and then the Vikings got to Greenland just when the temperature got bad. It started to fall because we were heading towards our next Ice Age. So that was a poor choice by Eric the Red. Nonetheless, what then happened, of course, was temperatures started to rise with the start of industrialization. As a binote here, we're giving a talk. This is the Manx Geological Survey on the 15th of November at the Manx Museum on what climate change in the rocks, so what's happened in time. It's an interesting story, I think, so if you want to come to that, of course you're invited. I'm going the wrong way, let's get the forward down. So start of industrialisation, which basically meant coal, and then oil, and then gas. And that's when emissions rose way beyond natural increase. And just to say, what happens with emissions is we get solar energy coming in, it reflects back from the Earth's surface, and some of it goes back to space, but some of it is captured by gases, including carbon dioxide and methane. This is the greenhouse gas effect. We've published how it works with this actually relatively simple formula. Nonetheless, the big calculations that the ICC do, the really complicated models, have been bang on prediction. There's no doubt that this is affecting what we're producing into the atmosphere, is affecting the climate. So 1850, we had 284 parts per million carbon dioxide. At present, it's 428, which is being accounted for about 1.2 to 1.3 average rise. The problem is we've got an awful lot of oil and gas still in the ground. It's been discovered that oil and gas companies want to produce. Now, if they do, then that means we're up at 1.8 degrees centigrade. This is not including coal. And if you look at everything that we're doing at the moment and don't change, then by before 2060, we'll be more than 3 degrees centigrade higher than it was in 1850. Now, this is a disaster for the climate, so we need to change that. So let's look at the Isle of Man. Most of our power comes from oil and gas. So once you look at heating and transport, of course, electricity is only, it's about a quarter of what we use. And that's responsible for about 550,000 tonnes of carbon dioxide a year. That's just direct from the Isle of Man. If we compare it to Denmark, we have district heating here, which means we burn less at home. We've got some electric cars, which of course means the electricity use is higher, and we have more industry. But if the Isle of Man wanted to be climate friendly, it wanted energy security, it wanted affordable energy because renewables are cheaper, we wanted to be independent of unpredictable fossil fuels, then wind and or solar is where we want to go. And certainly wind is the best, because if you look here on the right, this is from the Global Wind Atlas. It's produced here at the DT where I work, and red and orange means a lot of wind, and that's where the Isle of Man is really, really windy. You can see the Mediterranean mostly doesn't have much wind. The Azores here, down at the bottom left, has an awful lot of wind, but not our Azores. In terms, we're significantly windy, and there's a real resource for us. It also means that we don't need the maintenance of a wind turbine compared to, say, Pluro's power station is low, and it's a long lifespan. And it will furnish the green economy because this will attract industry. But the trick is choose clever, and that essentially means your own resources. There are a lot of distractions, of course. I can get us to move forward. Yes. Beware of the geothermal. The Isle of Man's too cold. It doesn't have the aquifers. There isn't a gas field. The 11225 did not find gas. Small modular nuclear reactors are often the future and very expensive. And wind turbines, really the things that kill birds, very unfortunately, but this is the things that kill them are cats and cars and windows and pesticides and overhead lines, increasingly climate change and wind turbines. We need to take it seriously, but really are a low risk for a bird in reality. So we then said, what can a wind turbine do? Can it actually replace fossil fuels if it's so good? And so we compared 10 megawatt wind turbine and compared to that to oil. And you would need about a 4 megawatt oil diesel plant, for instance, to produce what a 10 megawatt wind turbine produces, because it's not blowing wind all the time. Think of it over 25 years, and you would produce the same amount of electricity, 900 gigawatt hours, but the oil would produce 550,000 tonnes of CO2, the same as our annual production a year on the Isle of Man, and a wind would be less than 15,000 tonnes, and that's in the steel and the cement you use. And of course, the big thing is the cost of the oil, £90 million, and that doesn't include the wear in the engines. So imagine we did have our wind farms and solar parks. This was one that would work. It was about 120 megawatts of wind and 20 to 30 megawatts of solar. This would be for 9 days in January. It's all historical data here in terms of the black line, which is what we currently use. You see daily we go up and down in our electricity use between 25 and 80 megawatts. And the wind and solar, of course, varies with the weather and the daylight. So we get times of surplus power when we've got too much for the Isle of Man. And we've got times when we've got deficit, when there's just not enough because the wind isn't blowing, believe it or not. Now, of course, if we were buying the time when the surplus it's quite cheap, because the rest of the UK and Ireland is producing wind power at the same time. And the time when there's a deficit is very high prices. In fact, these cheap prices can actually be negative. People are paying you to get rid of their surplus power. If you looked over the year, green means what you would have to export is 100, in this case 100 megawatts of wind and 40 megawatts of solar, and red is what you'd have to import. This is over 365 days of the year. Essentially we'd have to export about 1/3 of our power from wind and solar and import when we weren't producing enough. And you would need an interconnect to do that. Our electricity grid isn't built really for, at the present anyway, for transmitting and distributing renewable energy. So there's an added cost there. So at the moment, the plan is to import 70% of our electricity, and 30% will come from the new wind farm onshore. As I say, the problem is the price, and it's unpredictable. It could be really expensive when you need to import, and you may not be able to export when you're producing too much wind. So we thought about this, and this is the Isle of Man in a power system. This is, and just to make this clear, Douglas here is on the right, Peel's on the left. We've got diesel power station in Peel. You can see Pulrose down here below the red transformers. So if we had green, which are the wind turbines and solar power, we would have to export quite a lot. We'd need a much bigger interconnector and import, and that's where it gets expensive. And just to show you, again, we've published a lot of this showing that energy prices are going up and down, and the blue in this case is electricity. This is 2021 to 2022, and you could be paying an awful lot for electricity when you need to import it. And anyway, imports are generally not good. You can't control their carbon emissions. Even an electric car is really expensive if you're thinking of carbon dioxide. So what is much better is if we could store our surplus to use it when we have a deficit. So the key thing here for the energy transition, the biggest thing is energy storage. And how do you store energy? Well, in Ireland, you'll need more of this, but one way is pumped hydro, where you have a lower reservoir and an upper reservoir, and you pump up into the upper reservoir when you have surplus, and you produce power from the upper reservoir in a normal hydro system when you need the power. This is what it looked like when they built it in 1974. You can see this upper reservoir. It's rather like a Max Hill. You wouldn't see it. I've been up to it. It's really almost invisible, believe it or not. And you have an underground power room with hydro turbines, which can reverse. They can pump water up and they can generate power. Pumped hydro is actually the cheapest. This is cost in euros. It's a logarithmic scale along the bottom axis. On the vertical axis is power capacity. And the great thing about hydro is you can build it big and it's cheap. Whereas if you look at batteries, which is the red line here, it's hard to get to big scale. It's the scale you would need for the electricity grid to fully store all the power you need. And it's expensive. They're really expensive, batteries. So you do need batteries, but you try to limit that. The other alternative, of course, the Isle of Man would be use all this offshore power that we may get to produce hydrogen. And you can run an island on hydrogen. It's developing technology in some respects, but we could run our cars, we could heat our homes with hydrogen. It's a little far off yet. You can't buy everything you need off the shelf. Now, here is a problem with wind, is it varies, it's intermittent, it varies with time, and that affects the power output, which affects the frequency, and to stop all our electrical equipment breaking down, we have to keep the electricity. The MUA effectively keeps the electricity around about 50 hertz. If this is very quickly, this can cause a problem to the grid. So, if we go back to the Faroes, what do? They've got wind, they're powering the Suðuroy with 100% wind often. But of course, the wind comes in and out in the Faroes, can be hurricane force and then drop to nothing in time. This is a little graph showing over minutes, 5 minutes in fact, that the power from the wind turbines just dropped away for a minute. And that would normally cause a problem on the grid. In the old days it would have. It's like switching off your Pulrose power station. But what they have is batteries, and these batteries kick in. They also have something called a synchronous condenser, which is essentially an engine moving. It's a turbine that keeps moving, it keeps the electricity stable. And it also has some solar and hydro power to help stabilize the wind. But the main thing is the batteries. So you can see here at the top, grid frequency has stayed constant, even though the wind power dropped away. And this was because the batteries kicked in immediately to balance the lack of wind. And so that's the answer for very short term. Over a minute, the battery is the answer. Over more than a minute, hydro is the best. So we've been looking at what you would need in the Isle of Man. It's between 20 and 120 megawatts of hours of batteries, which is 120 is big, 20 is what they've got on the Faroes, and probably a synchronous condenser. You can convert Pulrose to be one of these, which helps keep the whole system stable. But the best, again, would be to have a couple of hydro project schemes, plus batteries, small, limit that because they're expensive, and then you've got a working system. And in fact, it means if the interconnector goes down and you don't build it, then in fact you can run the island self-sufficiently with that sort of 100 to 120 megawatts of wind plus some solar. Now, of course, you think this is an awful lot of investment. This is what does this mean in terms of costs? And if you think of all these islands, a lot of them are doing wind. So what's their price of electricity? Well, it's all lower than the Isle of Man. The best example, really, because some of them are connected to prices in Portugal, for example, like the Azores. And if we think of the Faroes, they're paying about 22p a kilowatt hour, and that's all despite all the investments they're making versus 28.5 in the Isle of Man. If we went the renewable way, then the calculations, the modelling we've done would say that with current consumption it would be about 25 to 40% cheaper our electricity, with a big savings in CO2. Of course, we'd also need to do the transport and heating. So, conclusions. The island, if we do it properly, it will thrive with renewable energy. Yes, our vision may change depending on where you put wind turbines, but yes, solar parks are less visible, but we need to choose clever, and we can be independent and have sustainable energy. It's relatively straightforward developing wind and solar nowadays, especially for the private sector. It's much more straightforward than building a nuclear power station, for sure. The lights won't go out with renewable energy as long as we have the energy storage. But of course, what's been missing maybe is the public engagement. We need to include the community, and that means that we all benefit from the investments and take part in the decisions as well. There are issues. We don't necessarily have all the skills we need. If we're using heat pumps, for example, we have our habits. We're used to turning on gas cookers, perhaps. We're used to jumping into a petrol-fueled car, and there is a lot of resistance to change, as we know. And of course, oil companies and companies that tank oil around the world are not that keen on in going away from fossil fuels, to be honest. We need to engage the land use community as well, the farmers. And as I say, I think there may be an error in one of our calculations for our current emissions. So anybody who'd like to take up that challenge, please contact me. The key thing is building the infrastructure now. We need to be able to transmit and distribute renewable energy. We also need to decide the rules so that investors are welcomed rather than turned away. So we've got an energy system model. We can release that on the Isle of Man. It would be good if everybody was part of that. But don't forget the heating and transport part. That's 75% of power, so that's where the strategy needs to include that. And our economy will flourish, and we probably don't need 15,000 new residents in that situation. And we will start to feel secure. There's a lot of things happening out there, and we're closer to a war in Ukraine than where I live. But we will save money. We should feel proud, and we can lead by example. And just to say, we've got another event on the 7th of November at the Gaiety Theatre with Imogen Bogal, where we're releasing a mobile app where people can try out their own renewable energy solutions. It includes nuclear as well, so you can see which works best in terms of cost and reducing emissions. And thank you very much for your attention.